symptoms of a bad throttle position sensor, testing, and troubleshooting issues. One part that frequently malfunctions in a vehicle is the throttle position sensor. In the past, cars were designed to employ a throttle cable to physically connect and attach both the throttle body and the accelerator pedal. This throttle cable helps allow for a manual opening of the throttle body when you press down the accelerator pedal through the cable. However, in the late 1980s, electronic throttle control systems began to gain widespread and were widely adopted, which eventually eliminated the need for a throttle cable, instead relying on electronic and sensor-based control of the throttle. Consequently, in modern cars and vehicles manufactured from the early 90s onwards, the throttle is managed by an array of sensors, with no physical link or connection cable between the gas pedal and the throttle body. An electronic throttle control system offers the advantage of smoother driving experiences without introducing a lot more electrical components that are prone to failure, potentially leading to throttle-related issues. So even with the fewer parts that make up the electronic throttle system of the modern vehicle, there is still one common component that frequently will still fail, causing the electronic throttle to encounter problems, which is the throttle position sensor. My aim in this video is to discuss the indicators, signs, and symptoms of a throttle position sensor failure, what happens if you disconnect the throttle position sensor, how to test a throttle position sensor, as well as the methods for diagnosing such failures. But before delving deeper into the topic, let's briefly discuss what a throttle position sensor is and how it operates. The throttle position sensor, TPS, plays a vital role in your car's engine management system. It acts as the eyes for the engine control unit, ECU, constantly monitoring how far you've pressed the gas pedal. This information is crucial for the ECU to determine the ideal air-fuel mixture, ignition timing, and other critical parameters for optimal engine performance. So when this information is transmitted to the electronic control unit, ECU, the ECU, in turn, relays the data to a throttle body actuator or motor, responsible for adjusting the throttle body's opening and closing in proportion to the accelerator pedal's position. Another crucial component is the throttle position sensor, tasked with gauging the degree of throttle body opening. This sensor relays its readings back to the ECU, ensuring alignment between the throttle body's position and the accelerator pedal's depression, while also regulating fuel delivery to the engine for optimum engine performance. So when the throttle position sensor malfunctions, the ECU receives inaccurate data regarding the throttle body's position. Consequently, incorrect amounts of fuel are supplied to the engine, resulting in disrupted air-fuel ratios and various performance issues. Now, what are the signs of a faulty throttle position sensor? Well, the signs and symptoms of a bad throttle position sensor include rough idling, erratic or hesitant acceleration, frequent engine stalling, especially when coming to a stop or idling, or inability to rev beyond certain RPMs or attain specific speeds, cruise control issues, and power loss. Also, you want to note that discrepancies between the throttle position sensor and the accelerator pedal position sensor readings will trigger a check engine light, accompanied by error codes ranging from P01120 to P01124, which is an indication of sensor issues. However, it's essential to note that other factors can trigger similar engine codes, such as a malfunctioning throttle body actuator or motor, a dirty or clogged throttle body, or a faulty accelerator pedal position sensor. Consequently, accurately diagnosing the problem can be challenging, as it may not always stem from the throttle position sensor itself. In such cases, relying on engine codes proves invaluable, as they pinpoint deviations in sensor readings, facilitating the identification of the affected component or system. To diagnose throttle-related issues effectively, several steps can be undertaken. If an engine code is present, assuming it's due to the throttle position sensor and replacing it is an option. Most throttle position sensors are relatively inexpensive, priced between $20 to $40, and easily accessible near the throttle body. However, if one prefers to avoid unnecessary expenses, a systematic diagnostic approach can be adopted before investing in replacements or repairs. So here is what to do. Begin by removing the throttle position sensor and cleaning it thoroughly. You want to try this first because the sensors are often exposed to dirt and moisture, potentially compromising electrical connections. And so cleaning the sensor and inspecting the surrounding electrical wires may rectify issues stemming from poor connections or contaminants. If cleaning the sensor yields no improvement, testing its functionality using a multimeter is advisable. While slightly more complex, this method involves wiring the multimeter to the sensor and observing voltage changes as the accelerator pedal is depressed. Failure to detect voltage fluctuations indicates a faulty sensor. Alternatively, if testing equipment or expertise is lacking, inspecting and cleaning the throttle body is the next step. Accumulated dirt and debris within the throttle body can impede its proper functioning, leading to discrepancies in sensor readings. Ensuring the throttle body is clean and free of obstructions may resolve issues attributed to throttle position sensor malfunctions. Should the throttle body inspection prove inconclusive, attention should shift to the accelerator pedal position sensor and any additional error codes present. Problems with the mass airflow (MAF) sensor or manifold absolute pressure (MAP) sensor can manifest similar symptoms and trigger corresponding error codes. Addressing these issues may alleviate the primary problem, indicated by the P0120 to P0124 engine codes. In rare cases where the problem persists despite these efforts, the throttle body actuator or motor may be at fault. Unfortunately, testing these components is more complex, often necessitating replacement based on suspicion alone. Given the relatively low cost and ease of replacing the throttle position sensor, it's often a prudent first step in resolving throttle-related issues. What happens if you disconnect the throttle position sensor? Well, disconnecting the throttle position sensor, TPS, just like the signs of a bad sensor mentioned above, will throw off your engine operation and present the following symptoms. Erratic engine power. Without accurate throttle position data, due to the absence of a throttle position sensor, the ECU will struggle to understand your driving demands, which leads to hesitation, surging, or a lack of responsiveness when you press the accelerator. You can imagine trying to adjust the volume on a radio without looking. That will be a guessing game that leads to frustrating results. Limp mode activation. In many modern vehicles, a disconnected TPS triggers limp mode. This safety feature limits engine power, prioritizing drivability over performance. While frustrating, it protects the engine from potential damage caused by an improper air-fuel mixture. Poor fuel efficiency. The ECU relies on TPS throttle position sensor data to optimize fuel delivery. With the sensor disconnected, the engine may run rich, too much fuel, burning more gas and reducing fuel economy. You might notice a significant drop in your miles per gallon. Rough idle. The TPS also plays a role in maintaining a smooth idle. Disconnecting it can lead to an erratic or fluctuating idle speed, causing vibrations and potentially stalling the engine. Check engine light. Most vehicles will illuminate the check engine light when the TPS is disconnected, alerting you to a problem with the engine management system. So now let's move on to steps in testing the throttle position sensor of your car yourself. How to test a throttle position sensor. So first, please note that testing the throttle position sensor involves working with the electrical components of your vehicle and could potentially damage your vehicle's electronics if done incorrectly. However, if you're comfortable with basic car maintenance and have a multimeter, here's a general approach to testing the TPS. Refer to your specific vehicle's repair manual for detailed instructions. 1. Locate the TPS. Consult your repair manual to find the location of the throttle position sensor on your specific vehicle. It's typically mounted on the throttle body itself. 2. Identify sensor connections. Locate the wiring harness connected to the TPS. The manual should provide a wiring diagram to identify the ground, signal, and reference voltage pins. 3. Multimeter setup. Set your multimeter to DC voltage mode. 4. Testing procedure. With the engine off and the ignition key turned to the on position, without starting the engine, Touch the multimeter probes to the appropriate pins on the TPS connector according to the manual's instructions. The voltage reading should change smoothly as you slowly open and close the throttle valve by hand. Specific voltage ranges for your TPS can be found in the repair manual. Values and testing procedures can vary depending on your vehicle's make and model. A faulty TPS reading on the multimeter doesn't necessarily confirm a bad sensor. There could be wiring issues or problems with the ECU itself in some cases. While the throttle position sensor is frequently the common reason for throttle-related problems, accurately diagnosing such issues requires a systematic approach requiring you to leverage engine codes, conduct thorough inspections, and employ diagnostic tools where necessary. Only will identifying the root cause becomes feasible. There you have it, guys. I hope you find this video to be helpful. If you do, please like, share, and leave a comment in the comment section below if you have anything to share. Also, subscribe to the channel to support the channel. I'll see you in our next video. Bye.